Hello students, this is Mr. Guo and I will be going through with you topic 5 of Lab WS. Topic 5 is on workplace safety. There are 5 parts and part 1 is on noise. Okay, let's get started. The learning outcome for this part include describe the harmful effects of noise hazard, explain how noise hazard is regulated in Singapore according to WSH regulations. WSH stands for Workplace Safety and Health. And thirdly, explain various noise control measures in terms of hierarchy of controls, which you learned previously. Let's start with the definition. What is noise? So let's differentiate sound and noise. Sound is what we hear when vibrations from the source travel through the air and reach our ears, right? And trigger the nerve, and we perceive it as sound. Noise is actually one kind of sound, but it's unwanted and excessively loud sound. Here are some common sources of noise pollution in the urban life: airplanes, music, emergency vehicles, so on and so forth. So, what are the harmful effects of noise? Before we go into the effects, we first need to understand how loud is loud, because noise is defined as excessively loud sound. So let's figure out how loud is really considered loud. So this is a so-called noise meter or sound meter. It starts from 0 all the way to 140. Yeah. And sound volumes are measured in decibels or dB, right? A few key numbers for us to remember. 60 dB is considered normal conversation level. It's about here. Pretty comfortable. 85 dB is level at which sustained exposure may result in hearing loss. So we should avoid long-term exposure. The key word is sustained exposure. So short-term exposure is actually acceptable. 125 dB is where pain begins, and we should avoid any exposure. So 85 is somewhere here. Therefore, we can still use hair dryers. You just don't use it for too long. 125 is rock concert, right? So you may want to reconsider before you visit your next rock concert. Now let's look at the symptoms of noise-induced hearing loss, also known as noise-induced deafness, NID. The first symptom is higher pitch sounds are hard to hear compared to lower pitch sounds. You feel like people are often mumbling. In fact, it's actually you have hearing loss. It's harder to hear sounds like sh, s, th, and f sounds. Words like shall, sell, fell may be hard to distinguish. The degree of hearing loss is usually about the same in both ears. So how bad is noise as an occupational hazard? Worldwide, occupational noise contributes to about 16% of disabling hearing loss in adults. In Singapore, over 900 workers were diagnosed with noise-induced deafness from 2017 to 2021, accounting for about 30% of confirmed occupational disease cases. So noise-induced hearing loss is about 1/3 of total occupational disease case in Singapore. Right? And in 2020, NID, noise-induced deafness, was the second highest contributor to occupational diseases after occupational musculoskeletal disorder, means your bone and your muscle pains. In order to fully understand the impact of noise as an occupational hazard, I put here a graph extracted from WSH National Statistics Report 2021. So this is issued by Singapore government on the statistics of WSH related cases. So this graph shows the number of cases of NID over the years. So the first thing we can spot is that there is a general declining trend over the years, meaning that it's under control, it's improving. So can you think of the reasons why? So there are several reasons. One is that companies are more aware of this issue and provide the employees with better PPEs, such as ear muffs, earplugs. They are also purchasing quieter equipment as engineering control, and they also implement other control measures, which we are going to learn later. Here is a quick summary of this graph. So what are the sectors that contribute to the biggest NID cases? Manufacturing sector is the biggest one, about 50%, followed by construction sector and the marine sectors. So just now we see the national level NID cases. Now I want to bring this case closer to you in case you think, hey, I'm not going to work in the factory. What has it to do with me? In fact, noise-induced hearing losses is very common among youngsters. This study done by Temasek Polytechnic students in 2014 found out that about 16% of students listen to music at more than 85 decibel for 8 hours daily. Remember, we should limit our exposure to sound level that's above 85 dB because that will cause harm to our hearing if we expose it to a long period of time. And interestingly, gender-wise, male students tend to listen to music at louder volumes than female students. It could be because of the genre of music they choose to listen to. So guys, please take care of your hearing and consider lowering the volume. Nowadays, it's not just listening to music, could be watching YouTube videos, could be playing computer games, mobile games. Next, let's look at the regulations on noise. Singapore has a regulation on the permissible noise level at workplace so as to safeguard the health and safety of the workers. So this table is actually extracted from WSH regulation bracket noise 2011. So this table actually summarizes the permissible exposure limit for noise. The first column here is the sound pressure level, dB, right? dB bracket A means this number is being calculated based on perceived hearing by our ears, because the sound level actually could differ depending on whether you are using your ears to hear or you are using a sound meter to measure. So this dBA actually take into account of our ears' ability to perceive the sound. So this is the sound level. This one is actually the maximum duration per day, means at this sound level, what's the maximum amount of time the workers can be exposed to that. If it's more than that, it's considered against the law because it will cause hearing loss or hearing damage to the worker. As you can see, as the sound level goes up, the time drops significantly. At 125 dB, where pain starts to occur, the limit is 3 seconds. And also, the regulation states that the maximum sound pressure level that the environment can give is 140. So a peak sound level exceeding 140 is considered no-no, right? Another no-no is shouldn't be exposed to 85 dB for more than 8 hours, right? Then at other sound level, you must refer to the table to know the maximum exposure time. Now let's look at the concept of equivalent sound pressure level. In the previous table, you see the equivalent sound pressure level of 85 dB over 8 hours is not permitted. So what does it mean by equivalent sound pressure level? Equivalent sound pressure level is defined as the level of a constant sound which, in a given period of time, has the same hearing damage risk as a varying sound. You look at this graph, then you will understand. This is the level of noise over a period of 8 hours. So it's fluctuating, it's not fixed. This is very often the reality because the machine sometimes gives a varying level of sounds. So how can we translate this varying sound into a constant number? Because we need to refer to the previous table to know the maximum exposure time, right? So there is some formula to do that. which is outside the scope of this subject, you just need to know that a varying level of sound can be converted into a equivalent sound pressure level. And in this case, it's 91 dB over 8 hours. So therefore, it's actually higher than the prescribed 85 dB. So this is not permitted. Now let's do a quick exercise to test your understanding on the topic of permissible exposure limit for noise. So in this quiz, you are going to determine if the following scenarios are considered exceeding the exposure limit for noise, according to WSH noise regulations. So guys, I want you to take a pause and refer to the table in the previous slide and attempt this question. Yeah? So don't just wait for the answer, try it yourself so that you know whether you get this idea or not. The first row, 80 dB for 5 hours. Does it exceed the limit? The answer is no, because the table states that the noise level, a starting noise level is 82 dB, and 80 dB is below that, so it's pretty safe. Second one, 87 dB for 9 hours. Yes or no? The answer is yes, because the maximum exposure time limit at 87 dB is 5 hours and 2 minutes. 9 hours is more than that. Next one is 90 dB for 1 hour. The answer is no, it has not exceeded the limit because the maximum exposure time limit at 90 dB is 2 hours and 31 minutes. So 1 hour is shorter than that. Next one, 125 dB for 5 minutes. The answer is yes, because the maximum exposure time limit at 125 dB is only 3 seconds. 5 minutes, I think you are going to go to the hospital. 125 dB for 1 second, just 1 second. The answer is yes, because it's strictly forbidden to have any exposure to above 140 dB. It will cause instant damage to your hearing. So don't do that at all. Okay, so after knowing the harmful effects of noise, now let's look at how to control noise. Remember, just now the WSH regulation states that the permissible level is actually a combination of noise level and time. So therefore, hearing damage actually depends on the noise level and exposure time. So there are actually two ways to reduce the risk of hearing loss. One is to reduce the noise level, one is to reduce the exposure time. Of course, above 140 dB is totally not allowed. So that one, you have to bring it down the noise level. So how can we do that to control the noise? Let's look at this inverted pyramid. This is our favorite tool in this subject. It's called the hierarchy of controls, right? And always the best way is elimination approach, followed by substitution, engineering, administrative control, and PPE approach. So we're going to apply the same concept to address the noise. First, let's look at elimination and substitution approach. Elimination approach aims to completely remove a very noisy process. For example, if you are drilling a hole on the wall, ask yourself, can I not drill the hole at all? Substitution approach is to replace a very noisy process with a less noisy one. However, both approaches are often very difficult to achieve due to technical constraints. As mentioned, elimination approach and substitution approach are very hard to achieve. Hence, we often resort to engineering approach, the next preferred method. Engineering controls are permanent and effective solutions to a noise hazard. Generally, engineering controls include substitution of noisy equipment for a quieter one. One example is Buy Quiet initiative, which I'm going to explain in a minute. Please take note the difference between substitution of equipment versus substitution of a totally new process. If we substitute a noisy process for a quieter process, that's considered substitution approach. If we never change the process, we only get a quieter equipment, it's considered engineering approach. Another example of engineering control is isolation of process or equipment by enclosure or barriers. Next is modification of noise source, for example, to reduce the vibration of the equipment. So as you can see, engineering approach very often is centered on the equipment or build a barrier around that equipment. So now let's look at one example of engineering approach known as Buy Quiet initiative. Buy Quiet is an initiative launched by National Institute for Occupational Safety and Health in the US, which aims to encourage companies to purchase quieter equipment to reduce worker noise exposure. So on their website, they give this example. These two saws look identical, but the below one actually is quieter by 10 dBA as compared to the top one. So these two saws, there's a clear difference in the noise level. Remember, 100 dB is pretty high noise level and exposure time is pretty less. It should be less than 1 hour. Therefore, if you are able to reduce the noise level by 10 dB, it's a significant reduction in the noise level. Therefore, the workers is able to use it for a longer period of time. And this difference equates to greater than 90% reduction in noise energy, resulting in fewer hearing loss injuries. Another example of engineering approach is sound barriers. Sound barriers are basically physical structures or physical objects that enclose the source of noise. So here are two examples. This one is in Singapore, the MRT sound barrier next to a block at Ang Q in 2019. So if you see something like this next time, you know it's not to prevent people from jumping down, but to prevent to reduce the noise to the surrounding. Next example, the sound barrier at construction site. It's everywhere. It's everywhere. So this technology, although looks quite intuitive, but actually it's pretty effective in reducing the sound level. NEAA actually encourages the following types of sound barrier for noise reduction at construction site. A noise enclosure, which they aim to reduce by 15 dB, noise panel reduced by 10 dB, and noise curtain reduced by 5 dB. Another example of engineering approach to reduce noise is to reduce vibration. Excessive vibration of machine surfaces and parts is a common source of noise. Remember, sound and noise after all is vibration of air. If the machine surface vibrate, you will cause vibration of air and cause loud noise. In addition to causing noise, vibration itself can decrease blood flow in our body extremities, such as fingertips. So therefore, if you put your fingers on a vibrating surface for a long period of time, you will result in numbing of your fingers. It's because it causes reduction in the supply of oxygen and nutrients to that cells. So don't do that, guys. So how do we reduce vibration? First, we can reduce the driving force of vibrating surface by maintaining a dynamic balance. So if the force is balanced, there is less vibration. We can also minimize the rotational speed. Slower the speed, less vibration. Let's look at some other ways to reduce vibration. A second one is reduce the response of vibrating surface. This means even we maintain the same driving force, if we are able to make the surface more stable and less likely to vibrate, it will reduce vibration. We can add damping, such as applying water and foam to absorb vibration. We can increase the stiffness of the surface, so it's less likely to bend and vibrate. We can also increase the mass of the surface, so it's more stable. We can also reduce the areas of vibration. In the case of water, we can reduce the velocity of water, means the flow rate of water, and hence the turbulence. At high speed, water becomes very turbulent, and this gives a very loud sound. You can try it at your home, some water hose or your tap. You increase the flow, increase the tap to increase the water flow, you will hear a louder sound from the pipe. It's because the turbulence, right? Next, let's look at administrative approach. Administrative controls should be considered if engineering controls cannot reduce the noise to acceptable level, because this is the next level of control, not as preferred as engineering. Some examples of administrative approach include workers who are exposed to noise level above 82 dB. This is a starting point. Above this point, we must limit the time. Should be removed from noise after reaching the permissible exposure time limit. They should spend the rest of the day in workplace lower than 82 dBA. Arrange that the machine does not run at full capacity if full capacity is not required to reduce noise level. Arrange such that high-level noise machines operations are done at night or other times when a minimal number of workers are around, right? In fact, that's why HDB set a regulation that renovation at the HDB houses can only be done at certain timing. For example, during the daytime, not at night when people are at home, or not over the weekends, right? That's the opposite of this. In the factory, it's the opposite. You want to do it when there are less people around. Last approach is PPE approach, personal protective equipment. Hearing protective devices include ear muff and earplugs, right? Ear muff offers better protection as compared to the other two, and it's more comfortable. Of course, it will be more expensive. Okay, this is a summary slide for this part on noise. Noise-induced deafness, NID, is actually the second most common occupational disease in Singapore after occupational musculoskeletal disorder. Many people are not aware of this because it's quite hidden. Workplace Safety and Health Noise Regulations 2011 sets the noise exposure limit for workers in Singapore. The limit is a combination of noise level and exposure time. Two key noise levels to watch out for from these regulations: 85 dB for 8 hours. Remember, this 85 dB is equivalent sound pressure level. So if it's a varying sound level throughout the day, you can calculate it to get the equivalent sound level. Another limit is over 140 dB is not permitted, not even 1 second. Main methods to control noise include engineering method, such as buying quieter equipment, create sound barriers around the noise, reduce vibration. Administrative method, such as better scheduling of working hours and use of PPEs. So that's all for this part. Hello everyone. Let's continue with the second part of topic 5, workplace safety. In this part, we are going to look at ergonomics, a very relevant and practical aspect. Let's get started. Ergonomics is all about use our body wisely. The learning outcome for this part are: describe the 10 principles of ergonomics, describe the use of ergonomics at workplace in preventing injuries. So what is ergonomics? The definition is that ergonomics is the study of working conditions, especially the design of equipment and furniture, in order to help people work more efficiently, comfortably, and safely. Benefits of applying ergonomics include reduced fatigue and injuries in employees, increased productivity, and job satisfaction. Here are some everyday examples of ergonomics. You probably hear something called ergonomic mouse, which is basically sculpted to fit the hand. So you can rest your thumb here to comfortably use your mouse. This could be useful for gamers who use mouse for extended periods of time. Ergonomic desk that is height adjustable to allow sit-stand dual use. It's pretty trendy nowadays. Many people choose to stand to work. Some even run on a treadmill to work. Ergonomic chair that provides adjustable head and back support, right? So this is head support, this is back support. During COVID, many people actually invested over $200 to buy a high-end ergonomic chair. My wife did that, and I went for an IKEA normal chair. Now let's look at the 10 principles of ergonomics. So these 10 principles tell us what to do so as to conform to good ergonomics practices. The first one is to keep everything within easy reach. Long reaches can strain our body. So tips are keep frequently used items and tools within reach. So everything within your easy reach, so that you don't have to reach out to it. Work at proper heights. Mismatching heights between people and workbench can result in awkward positions, contributing to fatigue, discomfort, or injuries. So tips are adjust the table, chair, and workbench to the proper height, right? If the table is too high, you put a stand below. If it's too low, you put something on the table so that it's the comfortable height. In fact, I remember when I did my renovation at home, the contractor asked me to test what's the preferred height for my counter, for my kitchen counter, because he wanted to make sure that when I cook, it's at the right level. The third principle is work in good posture. Awkward and contorted postures increase physical stress and often reduce strength. So the tips are sit and stand upright, following the natural S-curve on the spinal column. Don't twist your body or neck for extended time. Avoid forward head position. So as you can see, this is bad because this guy is leaning forward too much. And this is definitely wrong. In fact, this is my posture for many years until I realized it's wrong. And this is the best posture, right? Sit upright and your head is not leaning forward. It's in the same axis as your body. Reduce excessive force is the number 4. Excessive force can lead to unnecessary fatigue and injury, such as back injury. Why do we use excessive force? Very often it's because we are carrying or pushing very heavy things. So what are the tips? We should use the muscle of legs when lifting heavy things. Should use tools such as trolley or get other people to help when carrying heavy loads. So especially for guys, don't try to be macho and do things to carry things that's beyond your capacity. Number 5 is minimize fatigue. Don't overload a person's capacity. Watch out for static load, which is load that remains constant and does not change over time. Example, static load on your back and waist when sitting for long hours. So this static load is actually exerted by your own body weight, and this can cause fatigue. Tips: rest when feeling tired. Stretch your muscle and body to release static load. Static load resulted from not moving at all, right? Or assuming the same position for a long period of time. Number 6 is reduce excessive motions. Repeated and excessive motions increase wear and tear on our body. Trust me guys, after you reach about 40 years old, your body parts start to make noise and complain. You will know you have a problem. So the tips include use tools and to reduce manual labor, such as use an electric screwdriver, as shown here. If you need to do a lot of screwing, and arrange workstations to minimize unnecessary movement to get tools. This is similar to the first point, keep things within your reach. Number 7 is to provide clearance and access. Design work area with enough space to get the task done. Minimize obstructions between a person and the items needed to accomplish the task. As shown in this picture, there's no clearance for the leg because it's occupied by lots of loose wires. So don't put too many things under your table. Keep it clear, right? Tips: regular housekeeping of your desks and workstations to keep them uncluttered. Next tip is to minimize contact stress. Contact stress occurs when the body is pressed against a hard or sharp surface. This is different from static load. Static load resulted from not moving your body and receiving force for a long period of time. Contact stress is mainly about press against a very hard or sharp surface. It can inhibit nerve functions and blood flow. One common problem nowadays is called something like mouse wrist pain. The proper name is carpal tunnel syndrome, caused by overuse of computer mouse. Yeah, especially when you rest your wrist against the edge of the table, right? This will cause lots of stress to your wrist and affect the blood flow. And over time, your nerve will be damaged and you will feel numb or pain in your fingers and palm. So do this, right? And not this. So tips include use a mouse wrist rest, and you can Google it. There are such things. Avoid resting your wrists on the edge of desk. Number 9, provide mobility and change of posture. This perhaps is one of the most important and easiest to do, but very easy to forget. We should not stay in one posture for entire workday. Many people nowadays have a sedentary lifestyle, be it students, be it gamers, be it working adults. So the tip is very simple. At regular intervals, for example, every 2 hours, change your posture, move and stretch. I personally practice that. When I sit for about 2 hours, I would just stand up, stretch my body, or sometimes walk around for about 5 minutes or so. Next principle is to maintain a comfortable work environment. Provide adequate and comfortable lighting. Avoid temperature extremes and excessive noise. Right? So tips include get a good quality LED lamp on your desk. Avoid too dark or too bright lighting. Guys, trust me, this is a very good investment because nowadays people use computers and phones for a very long period of time. If you don't have good lighting, you are going to damage your eyesight. Now let's look at some specific examples of ergonomics in the workplace. The first one is related to foot comfort and safety. Common foot problems include aching feet, blisters, calluses, corns, arthritis, malformations of toes, fallen eggs, commonly known as flat feet, and sprains. Common causes of foot problems include long periods of standing, hard flooring, and poorly fitted footwear, such as high heels, ladies be aware, pointed shoes, lack of arch support, too loose or too tight footwear. In the case of too tight, there is not enough for your toes. Wrong footwear not only cause discomfort and fatigue, they also increase the chance of fall, trips, and sprains. So do yourself a favor, get a very comfortable footwear. Some equipment or PPEs that people use to alleviate those problems. One is anti-fatigue mat. It's made of materials that can provide cushion to the feet. So they are relatively soft, not as hard as the floor. So such as rubber, carpeting materials, vinyl, and wood. So if you need to stand for a long period of time, consider getting an anti-fatigue mat. Safety boots and safety shoes, also known as steel-toe boot. It's a durable boot that has a hard protective reinforcement in the toe. So here is very hard that can protect the foot from falling objects or compression. This is more for safety reason, but also when you choose safety boots, choose one that fit the size of your feet. If it doesn't fit, it's too big or too small, it will cause lots of fatigue because very often the sole of these boots is pretty hard, so not very flexible. So you really need to find the right size for you. Next, let's look at ergonomics when using computer at desk. Many of us use computers for more than 8 hours a day. So it's pretty important for us to know how to sit properly. In terms of chair, the optimal chair should be height adjustable, provide good lumbar support. Lumbar means lower back. No obstruction on the desk to allow postural change. This is one of the principles mentioned. Provide clearance right here. So get yourself a good, comfortable chair. In terms of sitting posture, keep your eye level aiming at the upper part of the computer so that you don't have to lift up or lower down your head. Keep your monitor at roughly arm's length away. Sit upright and keep your head in line with your torso, so don't lean your head forward. Keep your lower back supported by the chair or a cushion here. Minimize bend at wrist. Another important thing to take note is how to carry heavy loads, right? Many people think this is common sense. You just use your back, just bend your back and lift up. Unfortunately, that's a wrong practice. What you should do is first get close to the load, center yourself over the load, and stand with your feet shoulder width apart. So not too wide or not too narrow. Step 2, squat down. Remember, you must squat down and keep your back in its natural arc. So don't overbend your back. You may kneel down with one leg if it's more comfortable, or you can choose not to kneel. Step 3, hold the load firmly with 2 hands. Keep it close to your body and use your legs to lift up the load in one smooth motion. So don't jerk during the lifting. You may lift with either one knee on the floor or both in squatting position. So what you shouldn't do is to keep the load far from your body and lift from a distance. This will increase your stress and strain on your arms and back. You shouldn't use your back instead of your legs to lift the load. And you shouldn't shake while lifting the load. So this picture shows the proper lifting technique. This is known as crouch lift or leg lift. Basically, you squat down, use your leg muscle to lift up in one smooth motion. This is known as the stoop lift or back lift. You never squat down, you bend your back and lift up using your back. And this is going to put a lot of strain on your back muscle, and this is going to cause injury. So what injuries will be caused by improper lifting? The main long-term injury resulting from improper lifting is lower back pain. 80% of back injuries occur at lumbar 5 to sacral 1, known as L5S1, located at the lower back. You can go back home, ask your parents or your uncle, aunties, or grandparents. Some of them may actually have these symptoms. My own father actually suffered from these symptoms, and he had an injury had an operation just last year. Right? The reason why this L5S1 is prone to injury is because it carries most of body's weight, especially when we are lifting. The soft gel in the middle of the disc bursts through the outer covering and presses on the spinal nerve root, causing pain. So this is an intervertebral disc. It's like a soft gel that provides cushion between two bones, the backbones. If we overuse our backbones, it will squeeze the gel out. When it's being squeezed out, it will actually sort of poke at the nerve in our spinal cord, therefore causing unbearable pain. This is a summary slide. Ergonomics principles center around 2 elements: good design of space and tools, and proper use of our body at work. The key principles behind keep our body in its most natural and comfortable positions, never overwork our body, use tools, not brute force, to do the work. In fact, in total, there are 10 principles, but they roughly centered around these ideas. When sitting, keep your body in upright position and back supported. When lifting loads, squat down, keep the load close to your body, and use your legs, not your back, to do the lifting. Lower back injury often occur at L5, S1 disc, often results from overuse of back muscles, such as frequent improper lifting posture. Hello everyone. Now let's look at the part 3 of topic 5 on machinery hazards. Machines are tools, and we should know the tools before we use them. So the learning outcomes for this part are listed here. They include describe the common types of machinery and mechanical hazards, describe the different types of machine safeguards, such as safety guards and safety devices, and describe the lockout and tagout lotto procedures to isolate energy source. So here are some of the common types of machinery hazards: entanglement, cutting, crushing, friction, and abrasion. Let's start with entanglement hazards. Entanglement may arise when part of worker's body, such as hair, hand, or foot, or loose items worn by him or her, such as clothing or gloves, comes into direct contact with the moving machine parts. To prevent entanglement, many factories require that non-hair of employees to be tied up or hairnet to be worn. Strictly no necklaces and jewelry on fingers and wrists are allowed. This is to prevent the possibility of entanglement of those things into the machine. Here are some possible entanglement into the rollers, into the gears and the screws. Next type of hazard is cutting hazards. Cutting hazards are present in machines used to cut wood, metal, or other materials. Machines or tools with moving cutting elements are particularly dangerous as they have the capacity to cause severe injuries. So it will continue to cut through your body. So here are some examples. This is a saw. Next one is crushing hazards. Crushing occurs when a part of the body is caught between two hard surfaces that progressively move close together, crushing anything between them. So remember, our humans is no match for machines. So here are some examples. I want to share with you some real-life examples, some accidents resulting from crushing. One common example of crushing injuries is caused by rotating rollers, such as in instant noodle machine and pasta makers. So basically, they have two rotating rollers that help press the noodle dough into a thin sheet, or press the pasta into a sheet. You should be very careful when you are wearing disposal gloves when you handle the noodles, because gloves may actually get entangled into the rollers. So it's the entanglement hazard when you wear gloves. Even you don't wear gloves, if you're not skillful, your fingers may easily slide into the rotating rollers and get crushed by the rollers. So here are two real cases. This one is at a noodle factory in Canada. A worker was feeding dough into a noodle machine and got caught in the gauge rolls. The worker sustained serious injuries. The company was fined, right? Another example is at a restaurant in the US. A chef was cleaning the machine when her hand became caught in two rollers of the pasta maker. She suffered 22 bone fractures. So do be careful. But on the other hand, don't be scared. I personally worked in the noodle for a number of years at Nestle R&D Center, and I personally had never had any accidents, because we know how not to come too close to the rollers with our fingers. The next type of mechanical hazard is friction and abrasion hazards. Rough or moving surfaces can cause burns or removal of skin and muscle. Even relatively smooth parts of machinery moving at high speed can cause friction burns as a result of contact. Some examples are fast-moving conveyor belts, pulley systems, and ropes. Everyday relatable example would be when you are using an escalator, when you rest your arms at the side, the belt, right, the moving belt. If you're not careful, you may actually get bruises if you move too fast, if you try to rest your arms on a fast-moving belt. After knowing the common types of mechanical hazards, now we're going to look at how to prevent the mechanical hazards from happening. So one important concept, or rather an important tool we use, is called machine guards. Machine guards are rigid physical barriers that enclose dangerous machine parts and restrict operator access to the danger areas. They protect operators by keeping them away from the dangerous parts of the machine. They come in different forms. This is a guard for the saw. This is a guard to enclose the pumps, right? Because the pumps inside got rotating blades, which can injure your fingers if you stick your finger inside. There are different types of machine guards. The first one is fixed guards. A fixed guard is a physical barrier that is permanently attached to a machine, for example, by the means of screws, to prevent access to the danger zone from any direction. It has no moving parts and completely encloses a dangerous part of a machine. They often require special tools to remove, such as screwdrivers. So these are the examples of fixed guards. They basically enclose the most dangerous part of the machine so that people will not be able to come close to that part. Here is a real-life accident resulting from improperly installed guard. So in 2017, a staff worked on a surface planer. As he fed a wooden block on the surface planer is a machine to cut the wood blocks. The wood kicked back, leaving his hand exposed to the planer's moving blade. He suffered lacerations on 4 of his left fingers and his left palm. The injured staff received stitches on 4 of his left fingers. Initial assessment showed that the guard was too high, allowing the fingers to access the rotating blade. So this was the RAM installation, which was what happens when the operators use this machine. This guard actually is more like a white elephant, not serving any purpose, because his hand can easily go in. By right, this guard should be lowered down to prevent the hand from entering, right? So there's another type of guard, which is adjustable guard. Adjustable guard is one that can be moved or reconfigured to the dimension of the work at hand. So one example is this adjustable guard on a saw, right? So we are able to actually move this guard. Another type of guard is known as interlocking guards. Interlocking guard is one that shuts down the power to the machine whenever it is opened or pushed out of position. Right? One common application of interlocking guard is this flour mixer used in the food industry for making bread, cakes, and noodles. You need to do the mixing in here. The flour mixer is installed with an interlocking guard. When the guard is open, for example, when the operator is adding flour or water into it, the power will be switched off and the mixing blade will stop. So this is the guard. So when the operator lifts it up to add water or flour, the power will be shut off. So the blade will not be moving. Why? Because if somehow accidentally the machine starts while someone's hand is still inside, then it's a very dangerous situation. It may actually cut the person's hand. Besides machine guards, there are also safety devices. The difference between safety guards and safety devices is that safety guards refer to physical barriers. Safety guards are also machine guards. Refer to physical barriers, permanent or adjustable, which prevent workers from coming into contact with the hazards. While safety devices refer to non-physical or non-direct measures to limit or prevent contact between workers and hazards and provide emergency response to a hazardous situation. Some common types of safety devices are presence sensing devices, such as safety mat and safety camera, two-handed control devices, and emergency stop. This is an emergency stop. This is a machine guard or safety guard. So this is a physical barrier, while this is a device to sound out the alarm. So some examples of a presence sensing safety device. As the name suggests, presence sensing devices are used to sense the presence of someone when near it or stepping on it. So the first one is safety mat. A safety mat uses pressure sensor to detect weight. When a weight is applied on the safety mat, for example, when an operator steps on the mat, a switch closes and sends a signal to immediately stop the machine, right? Because this is considered a very dangerous zone. Once you step on it, the machine will stop. For example, in this case, if you step here, and this is a dangerous part of the machine, you want the machine to be off while you stand here. A more advanced type of presence sensing safety device is known as safety camera. A safety camera is able to monitor the surrounding of a hazardous equipment or area. The detection zone of a safety camera is usually divided into warning and danger zones. If a person or object enters the warning zone, the system can be set to sound the alarm and slow down the hazardous machine. Should a person or object enter the danger zone, the system will trigger an emergency stop to shut down the machine. So you can see from this picture. So the danger zone is actually this red area, while the warning zone is this green, yellow and orange area, right? Another type of safety device is known as two-handed control device. It is a device that requires the operator to use both hands concurrently to activate the machine. Hence, no hand will wander into the machine when it is in operation. So it forces you to put both of your hands or your fingers on the machine to keep the machine running. Once you lift up one of your hand or your finger, the machine will stop, and therefore preventing injuries. In this case, operator has to press both buttons at the same time to start a power press. This machine is known as power press. The two buttons must be placed far enough to prevent being activated by one hand. Another commonly seen safety device is known as emergency stop. Almost all the big machines will have an emergency stop on it. An emergency stop, also known as emergency stop button, is designed to respond to an imminent incident or hazardous situation. When pressed, it will immediately shut off the power and stop the operation of the machine, preventing it from harming the operators. You may wonder why need this emergency stop. Can't the operators just press the switch, the power switch, to switch off? This is because sometimes the power switch is a bit small, a bit far, not so easy to reach, while emergency stop is almost always in the red color with a yellow ring behind, so it's very, very noticeable, and it's often placed at a very easy to reach location. So it actually allows the operators to immediately press it if he sees an imminent danger. To resume the operation of the machine, the emergency stop must be reset to operate a normal position. And there are three ways to release the emergency stop. One is the easiest one, push and pull, right? The second one is twist release, means after you press it, you must twist it in the arrow's direction to release it. Another one this one is the safest of all. You must use key to release it after you press it. Now let's look at the lockout and tagout. Lockout and tagout is a very important procedure to prevent machine injury, but it uses a different concept as compared to the earlier equipment. Earlier we learned about machine guards or safety guards and safety devices. They are basically physical barriers or some devices to prevent people from accessing the dangerous part of the machine, or to sound out the alarm, or to stop the machine immediately. While lockout tagout procedures are meant to isolate the energy source, right? Be it electrical, mechanical, pneumatic, or hydraulic, right? Pneumatic means using air, hydraulic means using water, right? After you isolate the energy source, then the machine will not be accidentally activated when you perform maintenance, repair, and installation of the machine. So in a nutshell, lockout and tagout, known as LOTO, is to cut off the energy supply to the machine from the source so that there is no chance that you will be accidentally turned on while you are performing maintenance. Because sometimes you are inside the machine, you are, for example, cleaning the blade of a mixer, and you definitely don't want the machine to accidentally turn on. So what are the lockout and tagout procedures? Below are 5 recommended steps for LOTO for hazardous machines, adapted from WSH Guide 9. The first one is to announce the shutdown. You should notify all affected workers that the machine is to be shut down, right? So that they will not attempt to turn on the machine. The second step is to shut down the machine, right? Proceed to shut down the machine via normal procedures, meaning that you just switch it off. No need to use the emergency button, just shut it off using the normal switch. Next, disconnect all energy sources. Disconnect all hazardous energy supply, whether electrical, mechanical, pneumatic, or hydraulic, by using energy isolating devices such as circuit breaker, isolating switches, or valves. Confirm that any stored energy found in spring, electrical, hydraulic, or pneumatic systems is dissipated before starting work. Because sometimes, even though you isolate the energy source, there is some stored energy within the system. You must dissipate that before you proceed. Otherwise, you may get injuries from the residue energy inside. Next step is the most important one. Apply lockout and tagout. Lockout, the word simply means to lock it up, right? To really lock the energy source so that no one can turn it on. There's no energy to be supplied to the machine wherever the lock is in place. Tagout means to put a tag, like a note on the machine to indicate that you are performing maintenance and the energy is being locked out and no one is supposed to open it. Yeah? So apply a lockout device such as a padlock over each energy isolating device to ensure that all hazardous energy source cannot be restored accidentally. Lockout devices must be durable and strong enough to prevent accidental removal. Each lockout device should be affixed with a durable tag to indicate the identity of the person applying the lockout. The tag serves as a warning sign that work activity involving the machine is in place. So lockout is to isolate the energy so that no one can turn the energy on, while tagout is to inform people that maintenance is underway and no one should attempt to open the lock. Last step, verify the isolation and the lockout. To check that the lockout is effective, because it could be you didn't lock it properly. The lock can be easily opened if you don't do it properly. So you want to verify that it actually properly lock the energy. Test the operating controls by putting or trying to put the controls to on position to confirm the machine is unable to start, right? Why? It's because your lock actually stop the energy supply. So even you turn on the machine, it shouldn't start. If the machine is able to start, means your lockout is not successful. The energy is not isolated successfully. After the test, return the operating controls to off position. Yeah, you don't want to do maintenance while it's in on position. Even you isolate the energy, still it's much safer if you turn it to the off position, because later you are going to turn on the energy source. Once you do that, if the machine is in on position, you will automatically start. Upon successful verification, proceed with maintenance and repair work. Yeah. So all the things step 1 to 5 is to ensure that while you do the maintenance and repair work on the machine, the energy is isolated and there is no chance for the machine to be activated accidentally. I know it's pretty long and a bit difficult to understand. Now, I think with these pictures, you can better visualize the process. So this is actually a switch box. Inside is the power switch, right? Every one of our home will have one of those boxes. You can go home today and check it out, right? So how do we do lockout is we apply this padlock, on this box, a switch box, and we apply individual lock on this padlock. Why got multiple? Is because there are multiple workers performing the maintenance, and each tag has the operator's name indicated, right? So you can only open this switch box when all the operators remove their individual lock. As long as there is one person has his lock on, you cannot open it, because it means that person hasn't done his maintenance work. This is another example. This is a power switch. You apply a padlock to lock the switch, so there is no way to turn it on. This is another example to do lockout for the water, the valve. So lockout not only applies to electrical appliances, but also to valves. Okay, this is a summary slide. Entanglement, crushing, cutting, and friction are some of the main types of machinery hazards at workplace. Safety guards provide physical barriers for the operators by enclosing the dangerous machine parts. Safety devices use indirect means to prevent or limit access to the dangerous machine parts and provide emergency response to a hazardous situation. Lockout, tagout, LOTO, is an effective procedure to isolate the energy source to an equipment to prevent the equipment from being accidentally turned on during maintenance. Hello students, now let's move on to the next part in topic 5 on electrical hazards. Okay, now let's get started. The learning outcomes for this part are listed here. Describe the common sources of electrical hazards at workplace. Describe the measures to prevent electrical hazards. And describe the correct wiring configurations in a 3-pin plug and common mistakes in wiring. Now let's first look at the consequences of electrical incidents. What types of incidents would happen? The first one is electric shock. Next one is electrocution. These two are similar but differ in the severity level. An electric shock is a effect felt by electric current moving through the body, while electrocution refers to a fatal electric shock. So this is more severe and more dangerous. Electrical burns is referring to a skin burn that happens when electricity comes in contact with your body. Loss of muscle control could happen when you got the electrical shock. Person experience painful muscle spasms. As a result, he cannot let go of the source of electric shock. Of course, this is very dangerous. Heart and organ damages. Electrical current can cause abnormal heart rhythm, lethal dysrhythmias, severely damages to internal organs. So these are hidden damages electrical hazards can cause to you. Fire and explosion. A short circuit can cause overloading of electricity and overheating in the wire that may cause fire. Now let's take a quick look at how an electric shock occurs. So a little bit of a physics here. An electric shock occurs when a person makes contact with a conductor, such as exposed wire. So you are directly touching an exposed wire and simultaneously contact the ground or another object that provides a conductive path to the ground. In that case, electricity will travel through the person as there is a complete circuit formed from the power source to the ground. In other words, your body becomes part of the circuit because your body completes the circuit. Therefore, electricity can pass through you and you would experience all sorts of the incidents we explained earlier: electric shock, electrocution, lack of muscle control, heart and internal organ damages, right? So in this picture, it illustrates what happens. So the current will flow from this side. By right, if the person is not touching the exposed wire, you come through here. This symbol means electric appliance, which uses electricity and then goes back to the electrical source. But if there is a short circuit, means the electricity will bypass the electric appliance and then travel through the person to the ground and back to the electrical source. So therefore, the person will get electric shock. Now let's look at some common sources of electrical hazards. What are the things that may cause an electrical hazards? One of the most common one is damaged electrical cords. Right? As shown in this picture here, the wire used for charging of the phone, the power cords used to charge the phone or a laptop is damaged. The protective layer, the insulating layer outside the wire is worn out and the wire inside is exposed. And this is pretty dangerous because if you use your finger to touch this, you may get electric shock. It depends on the current, but still it's a risk. So if you have such things, please replace it promptly, or you can wrap it with some insulating tapes to fix this part. Another one is defective equipment, such as in the case of low quality charger. For example, your charger cannot handle such high current because it's not a genuine product, and then it may cause a short circuit inside and then cause fire even. Overloaded plugs or circuits. As you can see here, you are overloading this adapter. You shouldn't do that. Another mistake is wire laying on the wet floor. If there is certain parts of the wire that's exposed, the plastic insulating layer is worn out and it's in direct contact with the water, it's pretty dangerous and it will cause electrical shock to the people who step on it. Now let's look at some unsafe work practices related to electrical hazards. First one is working with electrical equipment with wet hands or on damp floors. Remember, water can conduct electricity. So therefore, you should never handle electrical equipment with wet hands or on damp floors. Note, body's highest resistance to current is offered by the skin, 500 ohm to 1500 ohm. Water, however, will decrease skin's resistance to current flow and hence increases current passing through our body. The correct practice will be always keep your hands and the working surface dry before handling electrical work. Second, wrong practice will be use metal ladders to work on electrical equipment. Metal ladders provide a direct line from the power source to the ground. The correct practice will be place a rubber mat underneath the ladder to stop the current flow. This will offer extra layer of protection to you. Never wear insulated electrical gloves. Example, those made from rubber. Rubber is a very good electrical insulator. When handling electric work, correct practice will be wear insulated electrical gloves. You may ask, I saw some electrician who come to our house to install some electrical wiring. Never wear, electrical gloves. They just use normal metal ladders. It's because they are very confident in their skill, but that doesn't mean that's a best practice, right? In the workplace, in the factory, some of the equipment have much higher voltage and therefore much more dangerous than our domestic electrical systems. So therefore, it's even more important if you work in those environments to follow the proper practices. Electrical safety PPEs. Here are a few examples. One of the most important one is insulating gloves, also known as electrician gloves, which are made of rubber or other insulating materials. Rubber insulating sleeves, which offers extra protection for your arms. Rubber insulating boots, also known as dielectric boots. Yeah. So if you wear all of them, you'll be very safe. Just remember this, the higher the voltage of the equipment you are handling, the more PPEs you should be wearing. Because if there is any short circuit or any defective parts, without those, one electrical shock can be fatal. Here are some bonus content, especially for the physics fan, so it's not compulsory, but it will help you understand why gloves and the rubber mat helps prevent electric shock. In this case, this guy is not wearing gloves and he's stepping on a wet mat. Wet mat means it doesn't offer much resistance, electric resistance. So this is the power source at 240 volts. Electric current will travel in the live wire. This is the high voltage part. Electric current will travel in this wire. And then due to a short circuit issue, it will pass through this person to the ground and then go back to complete the circuit. So this person becomes part of the circuit. So let's say whether the electric current passing through him is high enough to cause any serious danger. If it's low enough, it wouldn't be much of an issue. So let's look at the calculation here. The human resistance mainly offered by our skin is 1500 ohm, while wet mat offers 0 additional resistance. So the current is calculated as voltage over resistance, 240 volts over 1500 ohm. You get 160 milliamp. This is fatal because humans' tolerance to alternating current is less than 100 milliamp. So it will cause enough damage to your body. Remember all the things we mentioned earlier, which include the skin burn, heart problems, internal organ damages, muscle, loss of control to the muscle, everything, right? So this is fatal. In this case, this guy is wearing a rubber glove or insulating glove, and the rubber mat is dry. So let's look at the calculation here. This glove, because it's made of rubber and has good electric insulating power, means very high resistance to electric current. It offers, I think it's 1 million, right? 1 million ohms. A human skin is 1500. The rubber mat, another 500,000 ohms. So the total resistance is about 1.5 million ohm. So the resistance offered by our skin is pretty negligible. It's mainly, the resistance mainly comes from the glove and the rubber mat. Therefore, the current is like 0.16 milliamp. It's much lower than our tolerance level of 100. So in this case, it's non-fatal. So this case clearly illustrates the importance of wearing proper PPEs to protect you against electrical hazards. Now let's look at how to correctly wire a plug. This is a typical 3-pin plug we can find at our home. Once we open the cover, this is what's inside. The first thing we notice is that there are 3 types of wire inside. They have different colors. The live wire L is the brown color one, the shortest one. A live wire carries high current, electricity current, to the electric appliance to provide the power. So it's pretty dangerous because it's high voltage. After the electric appliance use up the electric power, the electricity will be sent back to the power source via the neutral wire, which is the blue one. So neutral wire typically has 0 voltage, so it's not as dangerous. The last wire is the earth or ground wire, which is yellow and green color. It will be connected to the ground. This offers protection and safety to the users, especially in the case of a short circuit. This is a fuse. It looks like a battery. Inside it has a very thin metal wire which will melt easily upon overloading of current or short circuiting. So it will melt. Once this melt, it will break the whole circuit and therefore prevents overloading of the whole plug, which may cause a fire or electric shocks to the people. Now let's look at the functions of live, neutral, and ground wires. As mentioned earlier, live wire supplies current from the source to equipment. It has high voltage. It will have the same voltage as the source. In Singapore, it will be 220 volts. In Japan, it will be 110 volts. Neutral wire is the wire that carries electric current back to the source from the equipment. You will have 0 voltage. So this one is electric. This is the live wire. This is the switch. If you turn on, electric current will pass through, and then it will travel to here. This is the equipment or electric appliances that use the electric power to operate. After that, the voltage drops to 0, and then this is a neutral wire which carries the current back to the power source, and this goes on and on. Earth and ground wire is connected to the ground as a safety feature in the event of a short circuit. It has a 0 voltage. Right? In the case of a short circuit, somehow this wire is exposed and touch another conductive surface. Therefore, electric current is diverted to this alternative route and then go to the ground, right? So it's not traveling through the equipment itself, and it's pretty dangerous. But if we have a ground wire, then it will provide a path of least resistance to the earth. So even if a person touches here, the electric current will not pass through that person because the ground wire is made of metal, such as copper, so it has a much lower resistance than human. So electric current will prefer to travel through the ground wire instead of our human body. So this offers some protection. Let's look at some common improper wiring practices. There are 4 main types of improper wiring. The first one is improper use of a cord gripper. Next one is reverse polarity. Third one is failure to connect to the ground. And last one is short circuit. The first improper practice is improper use of cord gripper or cord grip. A cord gripper is this white color bar made of either plastic or metal, used to secure the end part of the electric cable so that they will not move. If you don't have this, if a person trips or pull on the wire, the insulating layer may actually come off. therefore the inside wire may be exposed. So this is to prevent that. And this is wrong because this gripper is actually gripping on the internal insulator, not external insulator. Because only when you do this way, it will prevent the internal insulator be affected. The second mistake is reversed polarity. Reverse polarity means the live and neutral wires are connected in reverse order, meaning that neutral wire is connected to where the live wire is supposed to connect, right? Most equipment can still operate even when the polarity is reversed because there is a complete circuit. However, if a short occurs, short means short circuit occurs, the equipment can be a short hazard without the melting fuse because now the live wire will not travel through the fuse, so the fuse will not function anymore. Continue to run even when the switch is turned off. Again, the switch is connected to the live wire, but now it's opposite, so it's no longer functioning. So in both cases, the fuse and the switch now are connected to the neutral wire, which is after the electricity has been used, so they can no longer function. So this is the example. By right, the brown color live wire should be connected to the fuse. In reverse polarity, these two, the order, are reversed. This is the correct configuration. This is another example that shows the danger of reverse polarity in light bulb. Not many people nowadays use this, but some people still do. In a light bulb socket, the screw threads, which are the thin black color lines, are neutral, right? This is a correctly wired bulb socket. The button at the bottom is live, right? So the button is high voltage, right? It's designed in such a way that it's more protected. It's at the bottom, so you are unlikely to touch it. But if in the case of reverse polarity, the screw threads become live and the button is neutral. So it's more likely that you may touch accidentally the screw threads, which is now high voltage. Therefore, it's more dangerous. This is what happens if this light bulb is wired in reverse polarity and there is some exposed screw threads and the electricity powers up this bulb and you touch the threads. Now you'll get an electric shock because now the threads are live, connected to the live wire and have high voltage. The third mistake is failure to connect to the ground. Earlier I mentioned the ground wire plays an important role as a safety feature because it's able to direct the electric current to the ground in the case of an electric circuit, therefore protecting the user. Most equipment can still operate without ground wire. However, if a short circuit occurs, for example, when the live wire accidentally touching the metal casing of an equipment, therefore the electric current will travel through the metal casing of the equipment, and the operator is touching the metal casing of the equipment, may get an electric shock, right? So the current have no avenue to flow to the earth except through the technician when he touches the equipment because there is no ground wire. So the only place for the electric current to go is through the technician. However, when a ground wire is present, then this current can be directed through the ground wire. So therefore, it's essential to protect the users. The last mistake is short circuit. The live and the neutral wire touch each other before the current passes through the load, meaning the equipment. Right? Or the live wire touches the metal casing of the equipment, causing the current to flow through the earth wire back to the earth. In the second case, it's not so bad because what happens is the equipment will not run because no electricity passes through the equipment, but because you still have an earth wire, so it will not cause danger to the operator, right? But in the first case, because the live and neutral wire directly touch each other, so there is going to be an overload of current, and then therefore cause melting and even fire to the equipment, right? The name short circuit means that electricity travels through an unintended path without going through the equipment, hence shortening the circuit. This results in excessively high current flowing in the circuit. This picture illustrates what a short circuit looks like. The battery provides the power source. The red color wire is the live wire. It has high voltage. It carries the electric current to the switch, right? The switch is on, so proceed. By right, it should go into the light bulb to light up the bulb. However, somehow these two cross over and both wire, the insulating layer is damaged, and therefore the metal wire are exposed and touch each other. So therefore, instead of traveling to the light bulb, it takes a shortcut and travel back to the neutral wire. So the electric current will basically travel in this route repeatedly. As you can imagine, as there is no load in this loop, in this circuit, and this resistance in the metal wire is very low, so the current will be very high. When the current is very high, it will cause overloading and then high temperature, and then may cause fire or explosion in the battery, and it's very dangerous. Okay, this is a summary slide. In this part, we focus on electrical hazards. Electrical hazards can cause severe harm to people and cause electrical fire. It can be avoided by wearing proper PPEs, such as insulating gloves, sleeves, and boots, and observe proper handling practices, such as replace worn and exposed wires, do not overload the extension cord, keep hands and wire dry. A 3-pin plug contains one live wire, which supplies electricity and connects to the fuse, one neutral wire, which retains electricity to the source, and one ground wire, which is connected to the ground to prevent electrical shock in the event of a short circuit. 4 common wrong wiring practices are improper use of cord gripper. We should always grip on the external insulator, reversed polarity, failure to connect to the ground, and short circuit. Hello everyone. Now let's look at the last part of topic 5, fire hazards. Let's get started. The learning outcome for this part are: describe relevant terms used in fire and explosion, such as fire triangle, flash points, classes of fire, different types of fire extinguishers. Apply the principles of ventilation, ignition, containment, exchange, and separation, vices for prevention of fire and explosion. Let's first look at the science behind fire. You may think you know what fire is, but you may not know exactly the science behind. A fire essentially is an intense chemical reaction that converts fuel into carbon dioxide and water. So it's actually a violent and intense chemical reaction. The heat and the light you see is the side effect of this chemical reaction. As with any chemical reaction, it requires certain activation energy, which is provided by the ignition temperature to start the chemical reaction. The chemical reaction of fire is an exothermic reaction, meaning it generates heat. So once you start it, as long as there is enough oxygen and fuel to support it, it can self-sustain itself and last forever. That's why it's dangerous, because this chemical reaction, it generates heat. It will sustain itself. That is why some wildfire or bushfire can last over a month, such as a 2019 to 2020 Australia bushfire and 2022 California wildfire. You may see on the news the wildfire goes on and on for over a month. And even though the government has sent in the firefighting team to try to put on the fire from the helicopters and from the truck, it's just very hard because the fire is able to sustain itself. A very important concept in controlling fire is known as the fire triangle. For a fire to occur, 3 key elements must be present, and these 3 key elements are known as fire triangle. The first one is fuel, second one is oxidizer, most commonly oxygen. So therefore some people may just put oxygen here. Ignition source / heat. So fire will not occur if any of these elements are absent or present in sufficient amount. So normally what happens is that there is fuel, for example, paper or alcohol or gasoline, and there is ignition source, for example, an open flame or a lighter, which set fire on the fuel itself, and at the same time there is sufficient oxygen surrounding that fuel, which start this chemical reaction. As long as all these three are present, the fire will continue forever. In fact, after the fire starts already, you no longer need the ignition source. It just needs to maintain the heat, which the fuel and oxidizer itself is able to sustain. Let's take a closer look at the fire triangle. As I mentioned earlier, the three key elements are fuel, oxidizer, and sources of ignition / heat. In terms of fuel, there are solid fuels such as paper, wood, textiles, plastic, metal dust, sugar, and flour. Some of them you may not be familiar. For example, metal dust, they are capable of acting as a fuel, as well as plastics, as long as the temperature is high enough. Liquids, fuel include petrol, diesel, alcohol, solvents, cleaning agents even. Gases include hydrogen. That's what we use to launch the rocket, because hydrogen provides a huge amount of fuel. It's a very good fuel, it's just very expensive. Natural gas we use in our domestic homes or some restaurants, they use natural gas. LPG, liquefied petroleum gas, is another one. You may see pictures of LPG ships which transport liquefied petroleum gas to Singapore, right? So in the LPG form, it's actually liquefied, right? So it's not really a gas, but once you use it, once the pressure is released, you will quickly become gas. Oxidizers include air, which contain oxygen, and other oxidizing agents such as peroxide. Source of ignition / heat include open flames, welding arcs, hot surfaces, frictional sparks, electrical equipment, static electricity, ignited cigarettes. People often think a source of ignition is open flames because they are more visible, or maybe sparkling arcs, right? But they don't know that hot surfaces, if it's hot enough, if you put a piece of paper on a very hot surface, it will also start the fire. Let's look at this concept known as flammable liquids / combustible liquids, right? So basically they are fuels. Yeah? They are the fuels in the fire triangle we mentioned, but we call them flammable liquids or combustible liquids. There is a difference between these two. A flammable liquid is a liquid that can be ignited easily due to its ability to easily give off a vapor that when mixed with air can start and sustain a fire. It has very low flash point. A combustible liquid is a liquid that is quite capable of being ignited but would require a higher temperature than flammable liquid, relatively low flash point. In short, both flammable liquid and combustible liquid can function as a fuel because they can give off a vapor. They are pretty volatile chemicals, and their vapors can start the fire. But the difference is that flammable liquid is even more likely, even easier to start the fire than combustible liquid because they have lower flash point. Later we will explain what flash point is. So by definition, if the flash point is less than 23 degrees and initial boiling point of less than 35 degrees, so that means at room temperature, right, it will actually slightly above room temperature start to boil. It's considered extremely flammable liquid and vapor, right? So they are typically very small molecules, which is very volatile. If the flash point is less than 23 degrees, but initial boiling point is more than 35 degrees, it's known as highly flammable. If the flash point is in between 23 and 60 degrees, it's known as flammable. If it's between 60 degrees and 93 degrees, it's known as combustible. So these are basically different the classifications of different levels of flammability. They are all capable of acting as a fuel. Earlier we mentioned the term flash point. So what does a flash point mean? It has nothing to do with the flash in your camera. A flash point is the minimum temperature at which sufficient vapor is given off to form a mixture with air, which is capable of sustained ignition when an ignition source is present. So a flash point is basically a temperature. It's a special temperature at which sufficient vapor is given off to form a mixture with air. Why must form a mixture with air? Because air contains oxygen, which is an essential element in fire triangle. When you have that amount of vapor and air, it is capable of sustained ignition when an ignition source is present. That means if you open a lighter right near that vapor mixture, then a fire will just start by itself. When a liquid is stored in an open manner at a temperature that is above its flash point, it is very dangerous, as any nearby ignition source will start a fire. Note, no direct contact with ignition source is needed because we are talking about vapor. So the fire could start just in the air itself. This is the GHS symbol for flammable chemicals. So you need to be very careful when you see this. They are capable of emitting vapor, which is capable of fire. So always cap them, put them in a container and put the cap properly, tightly, or better, store the chemicals in the flammable storage cabinet, which offers good ventilation and are separated from any ignition source. And it's also temperature controlled. Let's further explain how flash point works. This chemical, acetic acid, has a flash point of 40 degrees, so it's relatively low, right? When the storage temperature of this acetic acid is below its flash point, for example, you store it at 35 degrees, what happens is that it will still emit some vapors. It's inevitable, but the concentration of the vapor is not high enough to start and sustain ignition, even in the presence of ignition source. In this case, open flame, right? So you will not. So there you will only see some sparkle near the ignition source, but you will not. The liquid and the vapor will not be ignited, as there is not sufficient fuel to start the fire. When the storage temperature of this liquid is above its flash point, however, then there is sufficient vapor emitted in the air, mixed with air, and then when the ignition source is nearby, it will start the fire because there is sufficient fuel present. So the fire will start from here and then quickly pass through into the liquid. So the whole liquid and the surrounding air will start the fire. Flammable liquids are therefore dangerous as they can easily start ignition without direct contact with ignition source. To keep them safe, store them below flash point and keep them closely kept in separate cabinet. And also operate when you need to use them in the chemical fume hood, which offers good ventilation, and therefore there is no accumulation of the dangerous vapor. Then let's talk about another important concept known as a flammable limit. The flammable limit, also known as explosive limit, because once a fire starts, it will often cause explosion. So fire and explosion often go hand in hand. So therefore, flammable limit is also known as explosive limit. Indicates the minimum and maximum concentrations in air of a flammable gas or vapor at which ignition can occur. Concentration below the lower flammable limit, LFL, are too diluted to ignite due to insufficient fuel. Concentration above the upper flammable limit, UFL, are too rich to burn due to insufficient oxygen as the gas pushes away oxygen. Many students find this a bit counterintuitive. They thought the higher the concentration of the vapor, the more dangerous, the more likely to start a fire. But it's not true. Remember, fire triangle requires sufficient amount of oxygen as well. If you have too much fuel, means too much vapor, they will push away the oxygen, and therefore the fire will not be able to start and sustain. Gas concentration that falls within LFL and UFL are capable of ignition because it's at the right concentration. The combination of the fuel and oxygen is just right to start and sustain a fire. Do not confuse flammable limit with flash point. Flammable limit FL refers to the concentration of the vapor percentage volume in air, while flash point refers to the temperature of the liquid, right, at which it's able to start and sustain a fire. This is an example that illustrates how we can use flammable limit. Given the following information about ethanol, which is alcohol, identify which storage condition is prone to cause ignition. Ethanol has a flash point of 13 degrees and the lower flammable limit of 3.3% and upper flammable limit of 19%. This information can be found on the SDS sheet of the material. So below are 4 storage conditions. A, the storage temperature is 10 degrees and the ethanol vapor concentration in the air is 2%. Is this prone to cause ignition? The answer is no. Why? Because the temperature is below flash point, so it's not hot enough for it to generate enough vapor. And we also know the vapor concentration is is below LFL, so therefore there is no danger of starting a fire. Condition B, storage temperature 25 degrees and the ethanol vapor concentration is 3.1 degrees. Is it prone to cause ignition? The answer is no. The flash point is actually above. The storage temperature is actually above the flash point. So it's actually a potentially dangerous temperature because if you leave it in the open air without putting a cap, over time it will generate enough vapor to start a fire. However, according to our measurement, the vapor is only 3.1%. How come it's not in between these two, LFL and UFL, even though the temperature is above flash point? This is likely because it's stored in a well-ventilated area, or it's been properly kept, right? So there is no chance for the methanol vapor to evaporate into the air. So therefore, the storage temperature is only one factor that determines whether it will start a fire. You need to see other factors, such as is there good ventilation in the environment, therefore quickly dissipate the vapor, or is the chemical properly kept and stored in the flammable cabinet, so therefore there is no way for the vapor to actually evaporate and accumulate, right? So that's the case. The third condition is storage temperature is 20 degrees and the vapor concentration is 8%. Flash point is storage temperature is above flash point, so it's potentially dangerous, and vapor concentration 8% is in between LFL and UFL. So the answer is yes. It's very dangerous. Mainly it's because of this percentage of vapor, right? And the last one is 30 degrees and 25% vapor concentration. Is this prone to cause ignition? The answer is no. Why? Again, the main reason is the vapor concentration is above UFL, right? So in other words, it's too concentrated ethanol. So therefore, it will not start a fire, right? So I hope you understand how to make use of these two pieces of information to deduce whether there is a chance of fire or not. But in reality, it's pretty hard for us to measure the ethanol vapor concentration. You need special equipment, right, and measurement. So it's much more useful. I mean, it's much easier for us to measure just the storage temperature and use that as a gauge to determine the risk level involved. Also, we should always practice the good practice of capping the bottles of flammable liquid and operate in the chemical fume hood, store them in a flammable cabinet. Now let's look at the different classes of fire. In Singapore, fires are classified into 5 categories according to the materials. Class A fire are fires involving ordinary solid combustible materials such as wood, paper, fabrics, furniture, plastics, and rubber. Class B fire involve flammable liquids such as petrol, oils, kerosene, solvents, alcohol, paint, thinners. Class C fire involve flammable gases such as acetylene, ammonia, hydrogen, propane, propylene, methane, natural gas, LPG. Class D fire involve combustible metals such as potassium, magnesium, sodium. Remember, fire is a chemical reaction. As long as this fuel is capable of reacting with oxygen in an exothermic reaction, it's capable of starting a fire. Class F fire involve cooking media such as vegetable, animal oil, or fats in cooking appliances. After knowing the different classes of fire, we need to know what are the common types of fire extinguishers we can use to put out each type of fire. There are 4 main types of fire extinguishers listed here. The first one is dry chemical or dry powder fire extinguisher. It's suitable for class A, B, C, and electrical fire. Electric fire are not listed in the A, B, C, D, E, but it's another source of fire, another type of fire. Carbon dioxide fire extinguisher can be used for class B, C, and electrical fire. Foam can be used for A, B fire. Water can be used only for A. So as you can see, dry powder is most versatile, followed by CO2, and followed by foam, and water is actually the least useful one. So here are some pictures of the fire extinguishers. This one is the dry powder. CO2, you can clearly identify by looking at this big cone-shaped sprayer. This is water, and this is a foam. Now let's look at the details of each type of fire extinguisher. Let's first look at dry chemical or dry powder fire extinguisher. The dry powders are actually small particles of inert chemicals. Commonly used chemicals are monoammonium phosphate, potassium and sodium bicarbonate. So this one is actually our baking powder. So next time, if you have nothing else to put out the fire, you can consider your baking powder if it's in large enough amount, because it's an inert chemical. Mechanisms of action. The dry powders form a physical barrier known as a crust around the burning material and cut off supply of oxygen, and also traps the burning materials to prevent them from igniting other materials. So basically they just cover these burning materials and then cool them down. The pros of dry powder fire extinguishers are it's very versatile. As I mentioned, it can be used for class ABC as well as electrical fire. It has fast extinguishing abilities. The powder forms a screen between the person and the flame, allowing the person to approach the fire for more effective firefighting. There are some disadvantages as well. The residue is corrosive and sticky and may cause damage to the electrical equipment, and it's difficult to clean, right? Inhaling the powder may cause health problems. So even though dry chemical, you can use it for electrical fire, but be aware that it's not ideal because it may cause damage to the electrical equipment and it's very difficult to clean afterwards. The next type of fire extinguisher is carbon dioxide. CO2 extinguisher is most commonly used for flammable liquids, gases, and electrical fire. Mechanism of actions are displacement of oxygen. CO2 is an inert gas and it is able to reduce oxygen content by dilution or displacement to a point where it cannot sustain combustion, therefore breaking the fire triangle. It also has a cooling effect. Liquid CO2 discharged into the fire boils into vapor and remove heat from the fire to below its ignition point. So the key point to remember is that when we use CO2 fire extinguisher, what we spray out is not gas CO2 because it would be too little. It's actually liquid CO2. So the CO2 is being pressurized and liquefied into the fire extinguisher, that metal tank, and then when we spray out, it's actually the liquid CO2 discharged into the fire. It will quickly boil into vapor, and in the process, on one side, it actually displaces oxygen. On the other hand, it also cools down the temperature through the evaporation process. There are certain advantages of CO2 fire extinguisher. It's non-conductive and leaves no residues behind, making it perfect for electrical fire. So actually CO2 is the best one for electrical fire, especially if it's a very delicate type of electrical appliance, very expensive. You don't want to spoil it. As a gas, it can penetrate and spread to all fire areas, which cannot be easily reached by other type of fire extinguishers. It can be easily liquefied and bottled under pressure for a long period of time, so it's pretty stable. So don't worry about it, it won't explode. There are certain disadvantages. It has low cooling capacity and short period of extinguishing action, so it's not suitable for big fire, right? Because CO2, even you liquefy it, the amount of CO2 you can store in one tank is not that much, right? So it's not able to put out a large-scale fire. Hence, it's not very economical and effective on Class A fire. Therefore, we normally recommend CO2 for flammable liquids, gas, and electrical, which are special type of fire. It must be applied very close to the fire as spraying range is short. If you spray from a far distance, the CO2 will evaporate into gas before even come into contact with the fire. So you are wasting CO2 for no use. CO2 is not visible. Leaks can result in an asphyxiating environment, means low oxygen environment. Therefore, there is a slight chance of suffocating if there is a leak and the ventilation is not good. Next type of fire extinguisher is foam. Foam fire extinguishers contains surfactant to generate water-based foams that is able to coat the burning materials during fire extinguisher. Mechanism of action. Similar to dry chemical, the foam creates a blanket effect by covering the combustible material and thus cut off oxygen supply. It also provides a minor cooling effect. So what is a foam, right? Easiest thing you can remember is when you wash hands, right? When you rub your hands, then the foam will be created. A foam is like that. It's basically water. It's basically gas trapped in a water surface, right? So it's gas trapped in the water surface. So it's like bubbles, right? What are the advantages of foam? It's very effective against oil fire, Class B. which is able to float on top of oil and provides a blanket effect to cut off oxygen. The reason why we cannot use water for oil or liquid type of fire is because water is heavier than oil and it will sink, right? So the oil will still stay afloat and get in contact with the oxygen and continue the fire. But foam is different because foam is a mixture of gas and water. Therefore, foam is lighter than oil. So foam will stay on top of the oil to cut off the oxygen and offer a blanket effect. Foam also has higher fire extinguishing power than water. Example, a 6-liter foam fire extinguisher has the same fire rating as a 9-liter water. Because foam is a mixture of water and air, resulting in a higher volume when spread out. Right? The cons of foam extinguisher is that it cannot be used on electrical equipment as foam contains water, although not as conductive as water, so the damage is less compared to water. So the water is a conductor of electricity. If you spray foam on electric appliance, the small amount of water inside will conduct electricity and may cause danger to the people. One common foam fire extinguisher uses aqueous film forming foam AFFF, which contains fluorine compound. An environmental and health concern, fluorine-free foams are now gaining popularity. The old type contains fluorine, which is not an environmentally friendly chemical, right? The last type of fire extinguisher is water, perhaps the most familiar to you guys. But actually, water has quite a lot of limitations as a fire extinguisher. Water fire extinguishers are only effective in situations where the fire involves flammable solid, such as Class A. The mechanisms of action is that it's mainly rely on cooling by bringing down the temperature of the burning materials to below its ignition temperature to stop the fire. Because when water gets in contact with the fire, it will absorb heat and evaporate, and it will take off lots of heat from the burning material, therefore bring it down to below its ignition temperature. Water has one big advantage. It's the cheapest and most easily available. So it's very suitable for large-scale fire that's caused by solid Class A, right? So you will still see in a typical fire in a building, in a HDB block, the fireman will use the water hose and connect it to a hydrant and then use pump to pump the water to do the firefighting. So water definitely has its place because it's the cheapest and most readily available. High fire extinguishing capacity due to water's high specific heat, right? Specific heat refers to heat absorbed when water temperature increases, and the high latent heat of vaporization, the heat absorbed when water vaporizes. So it's much more powerful as compared to, for example, CO2 in terms of extinguishing capacity. However, it also has some big disadvantages. It cannot be used for Class B and C, right? Class B is flammable liquid, Class C is flammable gas. Why? Because water is heavier than oil and gas, hence will not be able to cover the burning surfaces. It tends to basically sink to the bottom and therefore not able to cover the surface. Although it's able to bring down the temperature to some extent, but it's not sufficient. And this action, the water flowing to the bottom of the oil and gas may cause further spreading of fire. Conductive, water is also conductive because water contains some ions. If you use distilled water, it's not conductive anymore. However, no one will use distilled water as a fire extinguisher. Hence, they cannot be used in electrical fire. It will actually make it worse, right? Because it may cause electrical shock. It cannot be used for combustible metals as well, because metals will react very violently with water. So you can't use for that. The last part is on how to prevent a fire and explosion by applying Weiss's principle. Weiss's stand for V, ventilation, I, ignition, C, containment, E, exchange, S, separation. First is ventilation. Good ventilation will rapidly disperse dangerous vapors given off from spills, leaks, or release from any process. This will help prevent vapor concentration from reaching the flammable range. Remember the LFL. Good ventilation will help prevent the vapor concentration to reach the lower flammable limit. Ways to improve ventilation include install fans and local exhaust ventilation system, such as shown here. These are local exhaust ventilation system. Good practice include to carry out the transfer of flammable materials under local exhaust ventilation system or via enclosed systems, for example in a chemical fume hood. The second good practice is ignition, or rather remove ignition source. So remove all ignition source from the storage and handling areas, especially from flammable and combustible materials. Ignition sources can be sparks, such as electrical equipment or welding or cutting tools. In fact, they are more, they often go unnoticed as compared to open flame. Hot surfaces, such as hot plates, or open flames, such as gas stoves and Bunsen burners, smoking materials such as cigarettes. This will help break the fire triangle. Next is containment. Suitably contain the flammable substance or its spill. Use of lidded containers or spillage catchment trays can help prevent spillage spreading. This will help prevent accident spills and leaking of chemicals that may give off flammable vapors. Here show some examples. This can or tank is known as safety can. It has a special design to prevent spills and leaks. It's suitable for storage and transfer of flammable liquid. So this is often used for flammable liquids. This is a chemical spill tray, which has this thing is known as a bond. The bond means the side barrier that can help prevent spilling into the external environment. And this is a bond trolley for transfer of chemicals. So again, you will prevent spillage onto the floor. The next principle is exchange. Basically, it applies the hierarchy of control. We can try to eliminate flammable substance from the process altogether by applying the principle of elimination. Exchange of flammable substance for a less flammable one by applying the principle of substitution. We can also consider other ways of carrying out the job more safely by applying the principles of engineering, administrative, and PPEs. The last principle is separation. We should always separate the flammable substance or process by a physical carrier, container, wall, or partition, especially separate from the source of ignition or high temperature processes. If possible, storage area for flammable chemicals should be placed far away from general storage area and the processing areas. Here are some examples. This is a flammable storage cabinet. It's properly labeled and it has good ventilation, and the chemicals are stored in the safety cans or special type of containers, which will completely cap the chemicals to prevent any evaporation. So as mentioned here, this is an example of isolated chemical storage space. So it's isolated from the rest of the factory. So it's far away from the sources of ignition and other processing steps. This is a summary slide for this topic. This is a pretty long and important topic. First, you need to know what is fire triangle. It's basically the three key elements to start and sustain a fire, which include ignition source or heat, fuel, oxidizer. Cutting off any one of them can stop fire. Flash point and flammable limit. They are important properties of flammable materials. We should keep The liquids below is flash point and outside of flammable limit. There are 5 classes of fire, A, B, C, D, F, referring to solid, liquid, gas, metals, and cooking oils. There are 4 classes of fire extinguishers: dry powder, used for ABC and electrical fire; CO2 for BC and electrical; foam for AB; and water only for A. We can apply the principle of vices to stop fire. They include ventilation, removal of ignition source, containment of the chemicals, exchange for a less dangerous chemical, less flammable chemical, and separation of flammable chemicals from other materials. So that's all for this part.